Homework 18, section 8.3, confidence intervals for population proportions, video 1. In the previous series of videos, we learned how to construct what was called a confidence interval when estimating the mean of a population. The reason we do this is pretty straightforward. Populations are usually so large and so dynamic in the sense that they are always changing that it's impossible to measure them accurately at one moment in time. So in order to measure something about a population, like a mean value, mean GPA for all students, mean age for all people in college, mean calories consumed daily by people in the state of Texas, what we do is we take a sample that's representative of the population, calculate the corresponding value for the sample, in this case sample mean, and then use the procedure for building a confidence interval to construct a range of values to estimate that value for the population. In the previous videos, we did that for population mean. So we took a sample, we took its mean, and then we calculated a margin of error to create an interval of values centered at that sample mean as a way to estimate a claim about a population or a value about a population. My train of thought just derailed. Confidence interval estimate. Oh yes, the center of that was called the point estimate, and we'll be looking at the same things, but this time in the context of proportions. Since the last series of video didn't mention proportions, I thought it would be a good idea to quickly review them. One variable for proportion is just a lowercase p, and that's the variable for population proportion. And what it measures is the percent of a population with a characteristic. For example, 30% of all Americans like broccoli, 49% of all college students own a car, or any other claim you can say about a population and a percent of it having some sort of characteristic. Just like with population mean, it's difficult to measure a population proportion because the size of a population is usually too large and the population is always changing. So we're going to attempt to estimate a population proportion by first measuring a sample proportion. Recall that the variable for sample proportion is read p hat. It's a p with a little pointy hat on top of it. But the sample proportion is just the percent of a sample with a characteristic. So in an effort to estimate the percent of a population with a characteristic, we start by calculating the percent of a sample with the characteristic, and that will be called the point estimate. Recall that a point estimate is just the sample version of a population value that we are trying to calculate. Point meaning a single point on a number line, meaning one value. So specifically, p hat is the point estimate for p. Just like in the previous videos, x bar, sample mean, was the point estimate for mu, population mean. Let's take a look at this example. In a survey of n equals 60 people on Facebook, x equals 35, think life after COVID-19 will be back to normal after 1 year. This isn't really that made up. I've actually put this survey on my Facebook page. Didn't quite hit 60, but the last time I checked, 35 of them had said yes. It's probably changed since then. Calculate a point estimate for the percent of all Facebook users with the same opinion. It's worth mentioning that I did say of all Facebook users because our sample was taken from Facebook, and so to be a representative sample, it should be representative of the population of all people on Facebook. All right, so whenever you're asked to calculate a point estimate for a value, first know what value you are calculating a point estimate for. We're looking for the percent of all of a population that has a characteristic. So this, the percent of all Facebook users with the same opinion, is a population proportion. So we're calculating a point estimate for p. And recall that in general, a point estimate for a population value is the sample version of that. So when we're asked for a point estimate for P, we're being asked to calculate P hat. Well, P hat is the percent of a sample with a characteristic. Well, this sample has 60 people and 35 of them have a certain characteristic. They think life will be back to normal in 1 year. So our proportion is 35 out of 60, and that could easily be converted into a decimal. In fact, on your homework, you will be asked to convert it to a decimal, to so many decimal places. Let me just glance at mine real quick. This one says at least 3 decimal places. Okay. Well, honestly, if you say at least 3 decimal places, that means it could be 19, or anything greater than 3. Well, we'll round it to 3 decimal places, 0.583. So a little more than 58% of this surveyed sample says, yeah, in 1 year, everything's going to be back to normal. And that's our point estimate for all Facebook users. Calculating a point estimate is easy, especially when it's proportion. You just ask what percent of the sample does something. So set up your fraction, divide it, and turn it into a decimal. In the homework, type the decimal, but when you're answering the question verbally, you should actually say a percent. But the problem with the point estimate is it's precisely that. It's a point estimate. It's one value. You could take a different sample and get a different value, and somebody else could take another sample and get yet a different value. Shoot, I could get a different value just by asking more people. So the problem with point estimates is they're not too reliable because they are 100% dependent upon the sample that you pick. That's why we create interval estimates, a range of values, for a better chance of capturing the true population value. So we're going to do the same thing that we did in the previous series of videos. We're going to take our point estimate, we're going to calculate a margin of error, and open up an interval by adding and subtracting that margin of error to this point estimate. The procedure for doing it is almost exactly the same as in the previous series of videos. We're going to find a point estimate, got it. We're going to calculate a standard error. We're going to find a z, and then we're going to multiply the z and the standard error to create the margin of error, which we will open up an interval with.